What we're going to look at in today's video is we're going to look at calculating the equation of the medians of triangles. Now, medians of triangles are one of the key properties we have to work with in straight lines at higher level mathematics. And in order to do this, the first thing we have to do is actually understand what I'm asking when I say what the median of a triangle is. Well, imagine I give you the triangle ABC, three coordinates like this that joined up. The median is a line which goes through a vertex to the midpoint of the other side. So imagine I do the median from B of this triangle. It would be a line, straight line, that would go through the middle of that line at some point. Let's call it M. Now what that means is it would take this line AC and split it exactly in half. So the distance on either side would be equivalent. So if I was to do the distance from A to M and the distance from M to C, I would find that the two of them are exactly the same. That's what a median is, essentially a straight line that does that. Now, what we ultimately want to be able to do is calculate the equation of this median. Well, there's a set of steps we can do. Imagine I give you three vertices of a triangle. So let's say I'm going to give you a triangle ABC. So I'll give you the point A. I'm going to locate it at the coordinate 4, -9. I'm going to locate the point B. I'm going to locate that 10, 2. And I'm going to give you a point C, which I'm going to locate at 4, -4. And imagine that I want to find the equation of the median from A. So the median that goes from the point A. Well, first thing you should really do is sketch a little diagram so you have a rough idea what it looks like. So you can imagine I've got a wee triangle. It looks something like this with my 3 points. Down here would be my point A. My point B would be up here. And my point C would look something like that. Now when it says the median from A, what that means is it wants the equation of the line that goes from there to a midpoint, let's call it M again, of that line CB. So it cuts that line exactly in half. Well, when we're doing something like this, there's a few things we have to do. Our first step, step number one for all of this, is we actually need to calculate the midpoint M. Now to do that, we have to think of our midpoint formula. Remember we did that a couple of videos ago. So we have to think of our midpoint formula for B and C. So to do this, we do 10 plus 4 divided by 2, and then we do 2 plus -4, and we're going to divide that answer by 2 as well. Doing this, 10 plus 4 is 14, divided by 2 we get 7. 2 plus -4 is -2, divided by 2 you get -1. So we know our point M is located at the point 7, -1. Now we want the equation of the line from A to M. We know to get the equation of a line, we need two properties. First, we need to get the gradient, and then the second thing we need is any generic point on the line. So let's get the gradient in the line. Now remember, gradient of a straight line, y2 minus y1 over x2 minus x1. And our 2 points in this case are A, so this point right here, and our new point M, which is given by 7, -1. Again, it doesn't matter which way around you label the points as long as you are consistent. So let's imagine that I'm going to take my new midpoint to be x1, y1, and I'm going to take my old point A to be x2, y2. What I'd get then is I'd end up with -9 take away -1 over x2, which is the 4 up there, 4 take away 7. So -9 take away -1 gives me -8 on the top. 4 take away 7 gives me -3 on the bottom. The two negatives cancel out, and I'm left with 8 over 3. So I've got my gradient here then of 8 over 3. Now remember when we went back to our equation of our straight line, the equation of our straight line was always given by the exact same formula, y equals mx plus c. And for this, we needed a gradient or a y-intercept. However, we also did investigate the second type, or the second way of writing it, with our y minus b equals m bracket x minus a. And remember this one, all we needed was a gradient and a point to give us the a and b on the line. Well, we've got 2 points, we could pick either of those and pair it with our gradient of 8 over 3, and we should hopefully get the right answer. So let's actually check that with both. So I know my gradient is going to be 8 over 3, so let's take our first example. So our first one was using the point A, which is going to be given by 4, negative 9. So I know then for this one I'm going to get y, take away b, so y minus negative 9 equals 8 over 3 bracket x minus 4. So at this fraction here, and I want to get rid of it as quick as I can, so I get rid of the 3 on the bottom by multiplying everything by 3. So multiply everything along the line by 3 and it gets rid of the fraction. So I get 3y minus 9 becomes plus 9, so that becomes 3y plus 27 equals, all I'm left here is 8 times the bracket, so I get 8x, take away 8 times 4 is negative 32. Now in a form of an equation like this, the ideal way to write it, instead of y equals mx plus c, would be ax plus by plus c equals 0. This is also an alternative form for the version of a straight line. So let's write this one like that. Take all of this across to this side here, and I'd end up with 8x, take away 3y, I've got then negative 32, take away 27, minus 59, equals 0. So it works out like this when I use the point A. But would it work that same way if I use my midpoint? Well, let's have a look and see. So let's take a version where I use my point M, which we remember was calculated as 7, negative 1. So in this case, I'd have y take away negative 1 equals, my gradient would still be the exact same, 8 over 3 bracket x, but this time it would be subtract 7. Same set of steps. Get rid of the fraction as quick as we can, times absolutely everything by 3. I get 3y, minus becomes a plus, so it'd be 3y plus 3 equals, and then multiply the bracket out again, 8x, take away 7/8, 56. Get everything again over to this side, and again I'd end up with 8x, take away 3y, take away 59, equals 0. So, it doesn't matter which point on our median we use, what we have to be sure that we do is the correct working when we do it. So when we're calculating the median of a triangle, we have to remember to follow these steps. First thing we need is what our midpoint is. Remember, we need 2 points on a line to be able to calculate the most fundamental part of it, the gradient, which then feeds into our equation of our straight line. Once we've got our midpoint, that's what we do, calculate the gradient. We then use our straight line equation, so our y minus b equals mx minus a version, with any point on a line, because we've just shown here it doesn't matter which of the points we use. What you should end up getting is the same answer. And in this case, for this example, we ended up with the same answer in both. 8x minus 3y minus 59 equals 0. That is the equation of our median. Following these steps, it's a pretty surefire way to be able to do it.